All right, you guys, in this video, we're going to continue our discussion about solving logarithmic and exponential equations, okay? Now, you guys may have remembered, but in previous sections, we solved exponential equations algebraically by expressing each side of the equation using the same base. That is, we used the one-to-one property of the exponential function. So we have this rule here. Okay, that said, if a to the u equals a to the v, then u equals v when a is greater than 0 and a does not equal 1. Okay, but unfortunately, not all exponential equations can be readily expressed so that each side of the equation has the same base. For such equations, algebraic techniques often can be used to obtain exact solutions. Okay, so let's try the following example. So our directions say solve 5 to the x plus 3 power equals 3 to the 2x minus 5 power. Now this is an exponential equation, and we know this because our variables are in the exponent, okay? Now before, when we tried to solve problems like these, okay, our first goal was to always get the base on both sides of the equation to be the same. However, in this problem, the base on the left is 5, and the base on the right is 3. There's no way that we can get those bases to be the same, okay? So what we are going to do, we're going to take the log of both sides of the equation, okay? So I'm going to say natural log of 5x plus 3 equals the natural log of 3 2x minus 5, okay? Now that I've written these problems as logs, we can use our log properties to help us bring those variables out of the exponent and down to the floor, as we've been calling it. So because these are logarithms, okay, our rule of logs say that exponents can come to the front of the log and they can become coefficients. All right, so let me rewrite our problem. Okay, now that I've rewritten it, okay, my goal is to solve for x. So that means I need all of my x's on one side of the equation and everything else on the other. So I'm going to distribute this natural log of 5 to these two terms and natural log of 3 to these two terms. So that's going to give me okay. All right, I'm going to move all my terms that have x's to the left side of my equation and everything else that doesn't to the right. So I'm going to subtract 2x natural log of 3. And I'm going to subtract 3 natural log of 5. And that's going to give me the following. All right, I need to factor out the x from both of these terms on the left. That's the GCF. When I factor out the x, I'm left with natural log of 5 minus 2 natural log of 3. And then I need x by itself, so I'm going to divide both sides of my equation by the natural log of 5 minus 2 natural log of 3. So my answer is x equals negative 5 natural log of 3 minus 3 natural log of 5 over natural log of 5 minus 2 natural log of 3. Okay, now depending on how they want your answer, okay, this answer that we just got would be called the exact solution. Okay, if they wanted the approximate solution, okay, it would mean that we were going to plug this entire quantity into our calculator. Okay, so I could plug it in just the way that it is. When I plug it into the calculator, I get this decimal, okay? And typically they will tell you where they want you to round. So I'm going to round to 2 decimal places. So my approximate solution would be x equals 17.56, okay? So just pay attention to how they want your answer. Exact means that they want you to leave the logs in the answer. You're not going to round or anything like that. And approximate is your keyword to let you know you're going to plug it into the calculator. Cool. I hope this helps.